Hello, welcome to 2.3.4. This is called Solving Linear Equations. We're going to put together everything that we've learned so far in this unit into solving these linear equations. So it starts off by saying to maintain the equality of two expressions, you can add, subtract, multiply, or divide each side of the equality by the same number. These are called the properties of equality. In the last problem, you applied properties of equality and numbers to find the solution to an equation. So far in this investigation, all of the situations have involved positive whole numbers. Let's think about these couple questions here for a second. Does it make sense to think about negative numbers in a coin situation? And does it make sense to think about fractions in a coin situation? You have used the properties of equality to solve equations involving pouches and coins. These properties are also useful in solving all linear equations. So let's go on to these linear equations and practice them. Part A says, for 1 through 3, record each step, meaning show your work for every step you take to find your solution. Then, check your answer by putting your solution back in the problem and seeing if it works. So we're going to start off with 1a here. 5x plus 10 equals 20. So the first thing I'm going to have to do is I am going to have to think about this as my gold coins and pouches situation. I have 5x plus 10 equals 20. 5x is the number of pouches, 10 is the number of coins, and then 20 is the total number of coins that I have. So the first thing I'm going to do is I'm going to subtract 10 from this side so I can get rid of 10 coins. Then I'm going to subtract 10 from the other side because I want to maintain equality. 10 minus 10 is 0, so I can cross that out. And I get 5x equals 20 minus 10, which is 10. So what I have now is 5 pouches equals 10 coins. How can I solve how many are in each pouch? Well, I can divide by 5, divide by 5. So I get x equals 10 divided by 5, which is 2. So my answer would be 2. Now, how could I check that answer? Well, what I can do is I could take the original equation which would be 5, and then instead of x, I put in 2. Plus 10 equals 20. 5 times 2 is 10. 10 plus 10 equals 20. Well, is this true? 10 plus 10 is 20. 20 equals 20. We did this correctly. So we got the same answer on both sides, which makes sure that we did this problem correctly. Now, if I look at problem B, what I see is 5x minus 10 equals 20. Now, here's an issue that we haven't seen before. Minus 10. What we've been doing so far with the coins and the pouches is we've added 10 loose change coins onto here. But now we have minus 10 coins. That doesn't make sense anymore to use our coin scenario. So we're just going to think of this as an actual problem. We just need to figure out how could I maintain equality on both sides of the equal sign here. So on A, what I did was I got rid of the 10 coins by minusing. For B, what I'm going to do is just do the opposite of what minus 10 is. I'm going to add 10 to both sides. Because what I'm still trying to do is get x by itself or get my pouches by itself if we were still working with pouches. So minus 10 plus 10 that's going to cancel out. That's going to give me 0. So I get 5x equals 20 plus 10, which is 30. So now my problem looks pretty similar to what I've been doing before. I'm trying to get x by itself, so what I want to do is I want to divide by 5, divide 30 by 5 as well. When I do that, I get x equals 30 divided by 5 is 6. So I get x equals 6. Now again, how could we check to see if this answer is correct? Well, what we can do is put the x back into our equation. So we get 5 times 6 minus 10 equals 20. 5 times 6 is 30. Then I have 30 minus 10 equals 20. 30 minus 10 is 20. 20 equals 20. Works out. I know I did that equation correctly. Alright, so now you guys are going to try C, D, E, and F on your own. Real quick, before you go on to number C, or letter C, what is going to be your first step to solving this equation? What is going to be your first step to solving question D? What is going to be your first step to solving question E? And what is going to be your first step solving question F? Let's go on to number 2. 2a, I see 1/4 x plus 6 equals 12. Now, this is again something we haven't dealt with before. We have fractions. I have 1/4 of x plus 6 equals 12. So I want to try to solve for x. So this, again, probably would not be a good situation to use coins because we have 1/4 of a pouch. But what we're going to do first is we need to get rid of this 6. So I'm going to subtract 6 from both sides. So we get 1/4 x. 6 minus 6 is 0, so I can cancel that out. And then 12 minus 6 is 6. So here's where it gets a little tricky. 1/4 x equals 6. We need to figure out what we can do to get rid of 1/4. In this case, when we have a fraction like this, what we're going to do is we're going to multiply by the reciprocal. Now, the reciprocal means that we are basically flipping our fraction. So instead of 1/4, it becomes 4/1. So we're going to multiply by the reciprocal as the opposite operation here. So I'm multiplying 6 by 4/1. Now, to do that, what I can do is make my 6 a fraction. So it's now 6/1. So now they're both fractions. Now I need to multiply fractions. So if I look over here on the left side, I have 4 times 1 and 1 times 4. What I'm going to do is multiply the top and multiply the bottom. So 4 times 1 is 4. 1 times 4 is 4. So I get 4/4x equals 6 times 4, which is 24, and 1 times 1, which is 1. If I divide 4 divided by 4, I get 1, which I don't care. I don't need 1. All I have is x then. 24 divided by 1, I just get the number 24. So my x equals 24. If I wanted to put this back into my equation, it would look like this. I'd have 1 over 4 times 24 plus 6 equals 12. 1 over 4 times 24. Again, I would make that into a fraction, so I'd have 24 times 1, which is 24. 4 times 1, which is 4. Plus 6 equals 12. Now, if I look at this, I have 24 divided by 4. 24 divided by 4 I know is 6. 6 plus 6 equals 12. 6 plus 6 is 12, so 12 equals 12, and we did this correctly. Now, if you look at B, our x, a number with the x on it, is 2. We have 1 1/2 and 6 1/2, so we have 2 mixed numbers. What I want to do is get rid of 1 1/2. I want to make it 0. What can I do to make 1 1/2 0? It's a positive 1 1/2, remember? So if I want to make a positive 1 1/2 0, I'm going to subtract 1 1/2. I'm going to do that same thing over here. Subtract 1 1/2. What do I get then if I subtract 6 1/2 minus 1 1/2? I get 2x equals 5. Solve the rest of that problem on your own. Solve for x. Once you're done with that, you can try C and D. See what you can come up with for those. And E. C, D, and E. Then look at 3a. We have 3 times x plus 1 equals 21. When I have a number on the outside of the parentheses, what does that tell me to do? Well, it tells me to distribute. So I'm going to distribute, I'm going to multiply 3 times x and 3 times 1. So 3 times x is going to be 3x. 3 times 1 is going to be 3. So now I have an equation that I can solve. 3x plus 3 equals 21. What would be the first step to solving this equation? I'm going to minus 3 from both sides. So I get 3x equals 18. What would be the second step to solving this equation? I'm going to divide by 3, so I get x equals 6. All right, follow that same process for B and C. Now remember, I have parentheses in here with a number on the outside of the parentheses for both of the problems. What are you going to do to solve that? What is the first step you are going to do to solve that with a number on the outside of the parentheses? Distribution. So distributing the 3 and distributing the negative 2 means you're going to do what operation?